Hello. How you guys doing today? Good? All right, so I'm going to talk to you guys about probably something you don't always see at a game developer conference, and it's really around what we're calling immersive design, which are really pivoting on enterprise applications for augmented mixed and virtual reality. I'm Brian Pene. I'm a Director of Emerging Technology for the Office of the CTO at Autodesk. And I've been focusing on augmented mixed and virtual reality probably for the better half of the last decade, before Moore's Law entered us to where we are now, where we've got these really amazing devices. And so I kind of cut my teeth taking heavy CAD data and putting it in game engines to simulate a design as if it was operating. And there's a lot of pains to that. So I'm going to talk to you guys today about what Autodesk is on the other side of Autodesk. And I'm going to show you some projects that we've been working on specifically that kind of cover these areas and why you should care. So before I get into what we're doing today, I think it's really important to just kind of give you guys a brief overview of the past. Are any of you familiar with either one of these pictures? If you want to raise your hand. So a few of you. So I think the point here is that there were dreamers years and years ago. Morton Heilig developed the Sensorama. This was the first cinematic, fully immersive experience. It had olfactory, it had sight, sound, wind. Ivan Sutherland developed the first head-mounted display as well. And these were back before computers were even personal. They were the size of giant rooms. But these were dreamers, and they believed in the power of these new tools. I think the other thing it's really important for you to know is back in 1989, in a small office in Sausalito, Autodesk created one of the very first virtual reality systems. It's called Siberia. This is Eric Gulichin wearing one of the power gloves, a Polimus power glove. And if this video plays, this is him actually, you've got to love the CRT screen, in one of the first VR systems actually navigating through AutoCAD with a Polimus glove 30 years ago, before we had displays that we have today and all the other things that are going on. So the reason I'm mentioning all this is because what we're experiencing today is nothing new. This has been dreamed about for years. The computing power has gotten a lot cheaper. It's gotten faster. It's gotten more sophisticated. We can do more things with it than we ever could before. I have more computing power in my back pocket now than the entire Space Station's command did just in 1984. So that's the real opportunity, is what can we do with all this amazing power that we have? These guys knew about it, and I will say, Eric Lyons, who is also partly involved, this is a great video that's on YouTube, and he talks about almost every single use case that we're exploring today in virtual and augmented reality. So I think this is a really important thing. Autodesk was at the forefront 30 years ago. So where we are today, well, today Autodesk is transformed from just a design company to a company that allows our customers to make anything. And no other company can provide the critical insight across industries. I'm sure you're familiar with the Autodesk of the gaming world, the Maxes, the Mayas, the Stingrays, but there's a whole other side to Autodesk, and this is the side that allows our customers to not just design, but to build, to make, to explore, and really everything that you see around you, from buildings to cars to bridges to tunnels to land and terraforming. And they have extremely complicated projects, and unlike games and media, they actually have to build physical things that, if done wrong, can either kill you or make millions of dollars of mistakes, or at best have to restart a project. So it's really serious business, and it's not taken lightly, this complexity. Well, on top of this, thanks to the advanced manufacturing technologies, the means of production today are rapidly changing. We're looking at how robotics and humans can work more closely together. There's an ever-evolving, savvier consumer class that prizes customization and individual utility over brand. And these things, in turn, are producing the kind of products that until now have never been seen. And as a result, the very nature of things themselves is changing. And it's estimated by 2020, it's predicted that will be over 50 billion web-connected devices. Huge amounts of data. We have a new era of agile development, and thanks to Autodesk being largely in the cloud, our customers can collaborate across borders, across platforms, and across devices on very similar projects, the same data. very complex data. It's now offset and the friction's been removed. And yes, they can start to now explore what we're seeing in the enterprise is exploring in virtual and augmented reality in these spaces, asynchronously collaborating across multiple platforms. The digital and physical are also being integrated deeply throughout the design process. People are using drones, they're digitizing the real world, they're using that as analysis to capture things. Advanced technologies in manufacturing and construction like 3D printing, microfactories, drones, and reality capture, those will all become the norm. They already are today. And the other thing is literally billions of dollars will be saved by instrumenting sensor devices onto the physical world that will give us the convergence of designing, making, and using something. Usually, a design's life cycle ends when a product ships, and that's it. But imagine now if you could use sensor data. If I ship a toy, I could look at how people use that toy. I could look at, in this case, what was developed that GE developed was to tell people that the automatic coast and braking system is going to wear out. That's saving them millions of dollars a year. So these are all technologies that are being implemented today to improve the bottom line for some of our customers. And let's not forget augmented and virtual reality, or the fourth wave of computing, as some are calling it, or contextual computing and immersive design is what we're coining it at Autodesk. These are all trends that will dominate in years to come, and Autodesk will be right there to offer its customers every opportunity to leverage the power of these technologies. So why did I tell you all this? Because what we're really focusing on here is around enabling technologies for design, engineering, and storytelling. Just like a game or just like entertainment, stories need to be told amongst broad stakeholders to get behind a decision, but also to make a well-informed decision. And this is where we can use technology. We can become almost cyborgs to instrument these technologies with ourselves to have a much better understanding of our designs of digital information and the context of that applied to the built environment. So I'm really interested more in how virtual and augmented reality can operate across the broader spectrum, and how it can help us perceive and experience the world in entirely new ways, to understand, to predict, and to make better informed decisions about the outcome of our designs and the projects we ensue. So if you think about how we can give humans a better fluency and a better overall understanding with digital information bridged to the real world. You know, with VR and AR, we have the ability to interpret very large, complex, continuous signals and distill that information through the spatial context of our work. So before I get into the projects, I just wanted to mention some of the use cases that are out there that we feel really are the powerful. There's several customer problems or opportunities that we can bring forth. The first one is just accessibility. How do we give people the ability to truly experience their designs in 3D? And not just visualize it, but experience it as if it's operating. It's animated, all of the metadata that comes along with it. How do we give people the ability to collaborate across borders, remotely, with designs in true 3D. There's new disruptive paradigms for design as well. Sketching, modeling in 3D, we're seeing these start to emerge. New ways of creative, of animating. I think you saw some of that earlier today in the previous talks. There's customized experiences where you're using multiple types of devices, multiple platforms, all synchronized together to have experiences. And then there's the contextual opportunity. How do I project data onto the real world, like you're looking at this tank tractor down below to look at loads, right? This is just giving humans a better intuition and a better fluency and a better understanding with data. As you could imagine with the load bearing, you'd have to be looking at a giant Excel spreadsheet and be a physicist. With this, you can see color information overlaid on the real world. So there's a lot of opportunities to solve. Now what I wanted to do is to show you some of the projects that my team, as well as others, have been working at in this space specifically. And then I'm also going to hand it over to Dave Tyner at the end to talk about some customer projects that we're really excited about to kind of show you that. Before I get into the projects, I just wanted to quickly put up this disclaimer. Basically, it's just to let you know that you might be seeing things here that will not be available or are not available in our products today, so please keep that in mind. Some of the stuff is, and I will mention what is. So the first project that we explored was last year. Last summer, we had 4 interns, and it was really around them coming and looking and exploring the concept of what does it mean to design in virtual reality. These were the interns that we hired. I think the other thing is really important to mention is I hired cross-disciplinary, multidisciplinary interns. These guys were very familiar with Unreals and Unity, but they also could speak design language. They also understood the utility of being a developer. So that helped them communicate really well. We also hired, one of the guys was actually an ergonomics guy. So because we care about task performance. Most of the VR and AR demos that you see today are about 5 to 10 minutes, and that's great if you're doing something for entertainment. But if you have something where you're in a prolonged use, you need to think about task performance and how well over long periods of time people can perform in these environments. So this was a really great team. All 4 guys had no experience with Stingray, which is the platform that we used at the time. They'd been using Unity and Unreal. I never gave them anything other than high-level problems, and I'll talk about those in a minute, but this was the process that they did. It was really around design through play. So every week, I had them do 2 prototypes. At the end of a week, they would test those prototypes, user feedback them, and then get that back into the design or not. At the end of the term of internship, they were able to combine all of this into an application, which I'll show you at the end. So what were we doing? So there's many VR devices out there today. We were starting to explore the HTC Vive. There's many. The problem with all of these devices is they all have different buttons and inputs and all of this stuff. And the question really starts to beg is, well, if I don't have a keyboard and mouse anymore, and I need to interact with all of this rich information, how do we create interfaces that allow you to do that with these devices? Yeah, voice control can work, but there's other input. One of the first things that we just started looking at was Windows and how is readability based on resolution, how is reachability, testing all of the results, and I'll just show you a video, kind of the real thing that they were doing is they just started out in Stingray kind of coding up these windows and looking at how readability is, how easy it is to access menu items, how easy is it to select, is it better to have a curved menu versus a flat menu versus all these different things. These are the reason that we did all of this was because you can't conceptually come up with something on a piece of paper and apply it in VR and expect it to work. You have to try it, you have to iterate through it. If you don't do that, and I'm probably not telling you guys anything new there, but it's important to people who are new. The other thing they looked at was this concept of a marquee menu, was really how do I create a menu? Now I've got Z depth in VR, right? And so now we can explore different spatial interfaces and look at different tool sets from a primary, secondary, and tertiary kind of a methodology. And so this is one of the menus that they came up with. And what was kind of novel is they used depth. They used the space of where you were to cycle through different modes of the menus, and then the touch interface to access primary, secondary, and tertiary parts of the menus. So this was just an exploration on how fast can you access various different complex information through menus. Not menus that you would expect on a 2D desktop, but spatial interfaces. And actually, I probably shouldn't even use the word menu because we're starting to think completely different about how these spatial interfaces work in VR. We looked at things like object selection. We looked at things like constraints, heads-up displays. How is it to directly manipulate something versus not directly manipulate? And so these were some of the tests they did around, manipulating objects, how to move an object, transform an object, rotate it. These things seem pretty straightforward. When you get in the VR and you try trying to pick objects that are far away or close up and try to manipulate things and do it fast, we have to do things better than we can do on a keyboard and mouse. Otherwise, it's not going to work, right? So we're not trying to just do stuff because it's cool. It actually has to be useful, and it has to be performant and really optimal for the task. So grid snapping was explored again. I'm just going to quickly kind of go through these. This was looking at how would you constrain. If I had that little, widget on the end of the chair, when the chair gets further away, I can't select that widget, right? So how do I provide a menu that allows me to, say, constrain on various accesses or whatever? So these were just explorations. At the end of the term, what they did is they put it into an entire application, which I'll show you now. Before I show you, the whole point of this application, both of the guys were architects, 2 of the guys, and they wanted to do something around interior design. They said, it's really hard in most of the software, so how can we look at doing sort of creating geometry in VR? And here you see where they're just starting to look at drawing splines and polygons and surfaces. But you'll start to see all the other prototypes that they did coming through in this application, where they took this entire apartment and looked at how would we lay this out in 3D space, and how would we control and manipulate different objects, how would we create different menu interfaces that would be intuitive or not, so that we could really do this better than we could do it on a 2D screen. We could do it better in tasks. And we didn't stop there. They actually started looking at how we do lay out cities, how would we lay out factories, all sorts of other things that really could use the utility of laying out 3D in 3D space in real time and doing it hopefully better. So there's the menu that we looked at, and it was really around how easy is it to select objects using a laser pointer. So there's a lot of challenges, and I want to be forthcoming about that, because we're not just trying to paint a rosy picture. Really, at Autodesk, what we're trying to do is roll up our sleeves and find useful, very well suited for people who don't have a lot of experience in these environments to really perform well and better than they could do on a desktop or a mobile device. So the other thing we're looking at is all of these wonderful marketing videos of all the different headsets that are out there. I will say that it's really confused the market a lot. I had a friend that said, "Oh, I'm sorry you're working on VR." He thought VR was just the cardboard experience. He didn't know that it was an HTC Vive. So the point here is there are various levels of immersion that you get out of this, and as much as we love the cheap and ubiquitous, and we are working on that, and I'll show you examples later, we're really trying to get the high-end, high-quality experience, because for a few $1,000s, you can have a very, very sophisticated system that does better than hundreds of thousands of dollars worth of hardware just years ago. So that's where we want to look at. So we've really been looking at room scale VR with the Vive. And with this device, the first thing we did is we integrated with two products. There's Autodesk Vred, or as the Germans say, Fred, and Autodesk Stingray, which is our sort of real-time engine. The first one, Vred, is really not meant to be a game engine. It's more for visualization. It's really where you're ray tracing, photorealistic quality in real time. So you're like 90 frames a second. This is the level of quality that you're looking to get out of it. I can scrub through this video if it plays back or not. So this is the kind of graphic quality that you get out of Vred, and it's really for automotive and industrial designers to truly understand how a car is going to look after it's been built. And as you can see here, it sort of blurs the line between what's real and what's digital. Well, Vred has always worked with VR for many years, but because, and in fact, a lot of our customers in the automotive space have been using this for years, but they've been using really high-end, expensive caves systems that are hundreds of thousands of dollars. The problem with this system is that not only do you have to spend all this money on the hardware and set up the system, but then you have to fly people in to have these experiences collaboratively. Well, as soon as we saw what you could do with the HTC Vive and a few $1,000s, the first thing we started doing is what can we do with this product to lower the cost of the hardware but still keep the experience? And so this was one of the first tests that my team, in collaboration with some of the others on the product teams, were doing with Vred. This was done on a sort of a green screen so that you can see better. But what we're really doing was looking at what do automotive design review people do? Well, they're like looking at the continuity of surfaces, and they're looking inside at all of these little details that you need to spot before something comes to life on the assembly line. And so giving them the right tools to be able to do that, things like section a car, cut it in half, or look at clay versus material sections, or be able to tag different notes to give a thumbs up or a thumbs down. These are all just kind of analog utilities of what happens in the physical space. How could we offset this to the digital and make it much more intuitive, but also carry some of that data back into the systems after a decision gets made? So the first thing we did was just with single users. But then we realized, wow, what if we could get people across borders to come in and collaborate on that same design at that same level? So last year at Autodesk University, and I'll just play a quick video of this, we kind of took that demonstration to the next level with virtual avatars. We had avatars coming in from Toronto, Montreal, Munich, and San Francisco. And then looking at kind of the things they wanted to do. So creating some hand gestures, basic like thumbs up, thumbs down. Let's not forget the high five. But really just saying what are the kind of the minimal things that they want to do at hand gestures. And then within this space, this is a Porsche Macan, was being able to look at different interfaces. How would I look at finishes when I'm inside the car? What's it like to sit in the passenger seat versus the driver's seat versus the back seat? And providing all of these input modalities to do this all in real time, while collaborating across remote borders virtually. And we implemented 3D sound to this and different gestures, and also made parts of the vehicle interactive. This was all about exploring for us. This was not like we're going to get it all right in one spot, but it was really about exploring what you can do and how much better that is than the traditional technology. So instead of buttons, we have these tools that you literally pick up. It's a section tool or a turntable tool or literally like a flashlight that you would hold in your hand. And being able to look at this design in real time and do this across multiple people. So we think that there's some real power to, obviously, with collaboration, not just for automotive designers and industrial designers, but across the board. And I'm sure in games and entertainment, you can see the same value. But we really want to take this part further. And this is one example with our product Vred. So Vred's good for sort of visualization, but it's not going to create you a very interactive, highly immersive experience. And so the question really, Bev, it's like, well, what if I have a giant building that I want to put into that and create it very interactively and put people through? Well, the problem with this is like, this is hundreds of millions of polygons, hundreds of thousands of objects. The average car has about 50,000 objects. And you know, the other thing is just one part can have hundreds of thousands of polygons. So if you live in the gaming world or the entertainment world, you're probably familiar. You model knowing this. What do you do with this type of issue, right? You spend a lot of time doing UV mapping and remodeling and all of this stuff. So how did we offset the friction? We created a solution called Autodesk Live. It's actually built, the client's built on top of Stingray, and then there's a cloud service that we use using Forge. And what we've really done is looked at how does an architect, they're in Revit, they're in a product called Revit, which is a building information product. They're not going to go out to Max. They don't know 3ds Max or Maya. They don't know DCC pipeline workflows. They don't probably know about UV mapping and combining objects and all these other things. What are they going to do? How are they going to get this into an experience where they can explore it with people? So this is a result of what they got. This result was generated by clicking a button inside of Revit. So this is our building information modeling product called Revit. And you literally click a button. It sends all of that data to the cloud. It optimizes the geometry. It optimizes all the objects. It knows a light's a light. It doesn't just give you a geometric light. It gives you a physical light with an IES data. It gives you all of the materials. It knows that a door is a door, so it automatically creates animations for those doors if you get close to it. So this is all about removing the friction for an architect to quickly go from a heavy, complex model that needs to be built to something they can actually show stakeholders and make better decisions about how a design would be in true 3D, right? Not on a 2D screen. And I don't know how much you're exploring design, but you get a whole lot more information in 3D space. I'd almost equate this to how we communicate. If you just hear my voice, you're probably only getting 20% of the conversation. My body language is 80% more. The same thing goes with 3D. If you're looking at 3D on a 2D screen, you're only getting so much information. As you build that up, you're getting more and more understanding. So that's an example that our product teams, that's available today. Autodesk Live, you can use that out of the box. Some of the other things that we're looking at is really looking at how do you go from design to fabrication. So this is how most automotive designers present their models. They actually have craftsmen that build models out of clay. Yes, still today they do this. They finish these models, and this is how they do a design review. The other thing I will say is a lot of the industrial designers and our customers think of themselves more as sculptors than they do as modelers. So we had early on, you guys are familiar with tilt brush, I assume? We had a couple of automotive designers sit in a chair with tilt brush, and they sketched out an entire interior of a car, and they said, oh my gosh, I can see all of the ergonomic attributes. I can see every aspect of how this car would be so quick. But the problem was you couldn't reuse any of the geometry, right? I mean, I can't use that to create the surface of the car and then fabricate it. So this is a product called Speedform Alias. It's built on Fusion. And why I'm showing you this is because you can see here, and this is sped up, yes, but they're modeling the car sort of by pushing and pulling. This is called T-splines, or more like NURBS modeling, where you're doing high continuity surfaces, and they're all parametric. It's not like modeling polygons. So we got inspired by this because we would see every time someone would walk up to a car or a clay, they'd say, pull this out a little bit or move this in. Can I tweak this slightly? So we started thinking, well, what's the analog to that? And so one of my engineers actually took our solid modeling library and wrote a plugin into Stingray so that you wouldn't just create sketches, but you could actually create true high continuity surfaces that were not polygonal, but actually stuff that you could fabricate from. And this was just the first prototype. This was really about looking at kind of that push and pull, or that manipulating, right? Grabbing a control point and tweaking it. So we took that whole concept and we said, well, maybe we could do a project around this, around looking at how a car body would be designed. So we showed this at Autodesk University last year. And this was a project that we actually did with a company called Hackrod, which were a bunch of stuntmen and movie guys from Hollywood that wanted to create a car that they instrumented with a bunch of sensors. They took this chassis and they drove it till the car almost broke. And then they fed it through our generative design product called Dreamcatcher at Autodesk. And the software figured out what the chassis would look like. It literally looked at that and designed it automatically. So then we have this beautiful chassis that's highly optimized based on sensor data. How do we actually create a surface body of the car? So this is where we started looking at, well, what if you could actually just design right on top of some kind of a reference model, and not just design polygonal data, but really high continuous surfaces. And so the demo had to be sort of self-guided, so we sort of did these things to make it a little self-guided. But here's an example of kind of what you're able to do. So you sort of start out and the car body kind of blurs away from you. And then you're able to kind of walk up, and yes, this was self-guided, but what we're trying to do now is more freeform. And you can start to click and create a spline. But the next thing we really want to do from this is actually create a surface. So it wouldn't just be a spline, but we want to now extrude that as an operation in solid modeling and create a body of a car. And just look at how people can do this interactively and more efficiently than they could do it in 2D. Why? Because you're seeing in 3D, you can move around, you can look at the attribute of that design in true 3 space. And then we also gave different other opportunities to try out different finishes or different surfaces and so forth. But that wasn't as much the point. The real point was really, how could we walk up and start to tweak control points on the surface and look at how I would manipulate that. So this was a start. We're now starting to work with industrial designers and automotive designers to look at where we can really take this, because next phase is to now stream this data out of VR and into a high-end system like Fusion 360 or Speedform that I can actually use to do CAM and fabrication on this. So another thing we looked at was really about how would we simulate and design a factory? What is the factory of the future? So robotics are huge today. Factories are extremely, extremely complex. And we started to realize humans and machines need to start working better together in these spaces. How do you design a factory? How would you lay it out and simulate it? And so the kind of inspiration behind this project that I'm going to show you came from a lot of these aerospace companies actually pay millions of dollars a year just to have somebody move a piece of equipment. Like literally shut the whole line down and go move the equipment 5 or 6 feet. And so we thought, well, there's got to be a better way than that. And at Autodesk, we have what's called our traditional factory layout tools, where you can lay out a factory on a 2D screen. We've had this for many years. Once you lay out the factory, you can simulate it with another product. But it still looks like a 1990s video game. It's not real time. It's not in true 3 space. So we took that concept and said, what could we do with that in VR? So the first thing that we did was we really needed to create digital avatars. If you're going to animate a factory, you can't use tools from a game engine or from the movies, because how do you know that's actually how the factory is going to operate? So what we ended up doing is creating digital avatars, and each one of these actually has an industrial physics simulation and sensor data. So the teams actually wrote an industrial physics plugin for Stingray. On the right-hand side is the industrial physics system. That's the true data of the robot now being driven inside of Stingray. So that was the first step. We had to simulate it as if it was operating. And then the second step was, how do we take going from this static inventor factory design model to this physics-based simulation so that you could truly walk into a factory and experience that factory as if it's operating, but not just visually. Be able to see all of the metadata about the sensors, about the devices, about how all of those devices interact with one another, and do it intuitively. So what you see here is really the fully simulated factory, everything from the robots, the machine, equipment, parts, even the forklifts that are running around. And like I said, unlike a regular animation, this is a true industrial physics simulation. So I can see the performance of the factory, the equipment, the efficiency, and the entire line with the ability to walk around in real time and play what-if scenarios about this entire line. So this is something that we really thought not only would be useful for factory designers to simulate, but what if they could lay out the factory? And then at the end, when they're happy, they can press build. So these are some of the applications we're looking at with factories, with industrial robotics for VR. The thing that's driving all of this data, all of this preparation of all of these heavy models is a solution that we have in the cloud called Forge. Forge is a platform of microservices. And it's really a variety of different services that allow you to do things like transcode data, render information, tie materials together, correlate and connect metadata with other disparate data, a whole slew of SDKs and APIs. And one example is what you saw where I could take a BIM model and bring it into VR. You can do these services to transcode files, thumbnails, geometry extraction, data extraction. So what Autodesk is really focusing on, because what we've realized is it's not really about VR or putting something to your face, it's about the data. It's about how do we get heavy data from one system into another and back out, and also connect that data with all of this other disparate information. And I'm sure if you're in games and if you're in entertainment, you can probably relate to that too. So this is the stuff that Forge is enabling. And one example is this is just a pure web browser, handles massively large models. This is called our Forge Viewing API, and our data connectivity API was able to take a materials cost database and connect it with this model to show me cost breakdown, to show me material breakdown, and ultimately to give me a better decision about the choices I make on the finishes for that seat. But imagine now you can bring that into VR. So now I'm not just making a decision based on cost, but I can actually experience it as if it's built and operating. So you're bridging the gap of the physical and the digital, and we're using the best of all worlds, right? The world is becoming infinitely computable. So these types of platforms, and again, they are moving into VR. So that Forge viewing system, this is a little demonstration one of my colleagues wrote called Vrocket. You can try this today. You can go out there with a very low-end device on a mobile phone, load up a model, scan it, and then share it and collaborate asynchronously with that device just on a Google Cardboard. Again, kind of removing the friction around data preparation and really making it easier for people to collaborate on really complex designs in the cloud. Forge doesn't just stop there. We've got rendering services on Forge that do photorealistic rendering from various products, Max, Maya, Fusion, Revit. Like I said, just click a button, render this in the cloud. It doesn't stop there. You're able to also render stereo panoramas, download those, string those together. So we're really trying to create a variety of services that work for both cheap and ubiquitous VR and AR, all the way up to high and costly augmented and virtual reality. So I'm going to turn this over because I'd like Dave Tyner to come up and talk a little bit about some of the customer projects that he's doing. I'm really excited about it, and he'll show you more what we're doing for our customers. So, Dave?
Thanks, Brian. Hi, everybody. So, yes. Hello. So my name's Dave Tyner, and I'm a solutions engineer here at Autodesk. And what my role is, I work with our large non-gaming, non-film customers to help them understand real-time workflows and how to basically get their stuff into VR. Not just VR, but real-time, because we all know VR is just an output of real-time, and depending on what you want to do with it, you have to get it into VR first. So that's basically what I do. So I'm going to be showing you a few of the projects that I work on. We've worked on a whole lot more. Unfortunately, can't show you all those for obvious reasons, but the ones we can show you, the ones I show you, we can show. So let's take a look at that. All right, so really it boils down to two main blocks. First one is getting the data in, right? So how do you get it into a real-time environment from wherever it's coming? Generally, that takes a course, takes its path through 3ds Max somehow. But as you saw, Brian showed you, you also have Live, right? Live, which does this conversion in the cloud automatically. It decimates data, or sorry, decimates geometry. It creates materials, animates things, puts things in place. It's really pretty amazing because anyone here visualization, architectural visualization spin? Okay, yeah, right. Hey. so yeah, it's painful, right? It's painful, and even just simple things. You know, you're talking about many, many mouse clicks, lots of time, and that's per cycle, right? Per time you want to do the conversion, it's pretty painful. So anyway, so that's the getting the data in part. And then once it's in, what can you do with it? You have to create functionality, and really, depending on the functionality you're trying to create, really dictates that workflow. But so here's a small example of a, yeah, so this is a unnamed coffee shop. And just creating some interactive functionality with the objects. This is done in the Stingray game engine. So, whoops. So as you can see, it's very dynamic. You can do a lot of things and have objects react in real time to what you're doing. And that table just got owned. So, all right. So really what's really important here is that we do this, and not just one time, but it needs to be scalable and it needs to be repeatable. Else it doesn't really have a lot of value because we don't do things one time. It's a very iterative cycle. Designs change. We want to see that change, experience that change now, not just see it. So this definitely has to be repeatable and scalable depending on the amount of data you're going to throw at it, right? So here's the video Brian showed. And so I'm just going to fast forward to the live part. So this is what you get in live, and live is pretty amazing for what it does, but it's limited functionality. So it does what it does, and it does it really well, but it doesn't do anything more. So when you want to take that to the next level, that's really where Stingray comes in. Stingray allows you to create any type of functionality, you know, that you can do in a 3D environment. You can do it in Stingray, including, you know, materials and interactivity and all that stuff, render to frames. So here is, so the visual quality, right, of live, good. But then we move into Stingray, right, and we can really start to build out the scenes, you know, play with lighting, do some things, make it look really, really nice, and all in real time. So we almost completely remove the need for big render farms and all the heavy stuff that you have to do and the time associated with and the maintenance and all that stuff. Now we can just do this rendering in real time, and it's a complete game changer for visualization. And of course, virtual reality being an output from that. So here's just playing in the viewport this scene. This is Georgia Tech. This is a customer of ours called Skanska. And Skanska really pushed forward and did this whole optioneering thing where, and I'll show you here in a second, where you're able to be in VR and just point at things and have materials change and have costs associated with those that change displayed immediately. So you're making all these decisions, all the data you need is right in front of you, and it's really powerful. And they're using it in their day-to-day workflow, and they're winning work. So pretty big deal. So let's take a look at another project from Skanska here. This is the LINAC, or Linear Accelerator. And Wes was trying to explain to me what this machine is and what it does and what it's for. And I just know that I don't ever want to be in one. And if you find yourself in this room, by the way, surrounded by 2 feet thick concrete walls on every side, ceiling and floor. And anytime that's the case, I don't want to be there. But what they're doing, they're helping the doctors understand from the patient's point of view, the perspective, some empathy. Hey, this room costs $5 million at the base. Let's configure it for a couple $1,000s more. Let's configure it, and from your customer, your patient's point of view, what does this look like? They're in this room. They're already probably having a pretty bad experience, and how can you make it a better experience? It's all about user experience. So this is what they put together. This isn't in VR, but it could easily be in VR. It's pretty much the same thing. All right, so here you're in the room, you're looking around, it's very, very cold, very white, very sterile. And now through a series of buttons you press, or controller buttons you press, you can start configuring the room and see from your patient's point of view what looks nicer, what looks better, what's going to give them a better experience. And this is, I mean, it's completely revolutionary and different from the way that they were doing it before, which is sending it, you do a render, how about this? Yeah, that looks good, let's try it the other way. Okay, back, render, back, how about this? And all these decisions now are being made in real time, and I know we're stressing that, but it's so important. And the response to this has been just overwhelming. They even on the jobs they don't get, the customer always comes up to them and says, hey, that was really incredible presentation, great job. By the way, you didn't get it because of this other reason, not because of your presentation. So good stuff. All right, so the next project I'm gonna show you today was this USS Arizona project. So this is actually a screen grab from Stingray. So this project came about, the National Park Service and AECOM. So National Park Service, who owns the site of the USS Arizona, it's leaking oil, right? Very slowly, but it is leaking oil. And they wanted to know how long until this thing erodes and we have a environmental problem in Pearl Harbor. How's that going to happen? So we had a team go out to Pearl Harbor twice, once in 2014 and once just last year. And they did a laser scan and a sonar scan of the USS Arizona at both times. They were able to take that data, bring it into Recap, which is our point cloud solution, line up those two scans and see what had changed in the 2 years, where it's eroding, what it's doing. Talk about powerful, I mean, unbelievable. So that's sort of the setup here, and since last year was the 75th anniversary, they said, hey, do you think, it's interesting, so I'm kind of a big history buff, and I love all this stuff. So getting the phone call, like, do you think maybe we could do a VR experience of the USS Arizona? It's like, oh my God, I won't sleep, I won't eat, just give it to me, So that's what we did. A guy named Jeff Wilson and myself, I got to give big credit to Jeff because he put the whole underwater scene together. There's a few levels, but that's definitely one of them. And so we were able to take that and present it to, President Obama was there and a bunch of other people. I mean, after that, let's start with the big one. Although he didn't get to see it, he probably saw somebody trying it and was like, dang, that's cool, I wish I could do that. So here's what, again, from a screen grab, fly through of the experience, and this experience is in VR, but this is all running on my laptop, and Camtasia running on top of it, so it's, if you see any hitches, that's what it is, but lots of data, huge geometry, like millions and millions and millions, 10, 15 million polygons, something like that. And we had to bring that in and decimate that down so that it's consumable in VR. And we did that through a combination of a product we have called Remake, and also used Simplygon for that. Did a bang-up job, but we did, definitely did a combo on that one. But pretty amazing. So, and that really speaks to the power of VR, right? So as before, this had just been a visualization with some cool renders. Now, there's very few people on the planet that can say that they swam with the Arizona. They were down in it. They saw it. They understood the perspective. When you understand that the ship sunk 30 feet, and I mean sunk as in collapsed in on itself 30 feet. And you're like, wow, that's a lot. But when you're standing at the base of it and you're looking up and you see like what 30 feet looks like and the amount of steel that just had to be just like, dang, that is insane. And that gives you a whole new perspective on just how, I don't know, the impact, the scale of things. It's super impactful. All right, so that was Jeff's level. He did a great job. Thank you, Jeff. So then I sort of got crazy and ran with it. So I created this level of Oahu where it shows the flight paths of the different, you have the high altitude bombers and the torpedo planes. There's a museum level where you can go in and the survivor stories, the big blocks there, you can walk up, you touch one, and you can listen to their stories, where they were that day. There's only a few survivors left. And very emotional stuff. I mean, that's the thing. The feedback I got was like, wow, wow doesn't cover it. It's like impactful, like I felt it. I was emotional about it. And that's really what the sense that it gives you. But also, what's so crazy and cool, and I worked with VR every day, for a long time. Well, a long time, right? As long as VR has been around, I've been working on it, and I'm still surprised at how moved I get. But so then we have the Arizona out at sea, right? And it's cruising along at sea, and there's like the sound of the wind and the waves splashing. But you can say, right, that I was on the Arizona out at sea, like I know what that feels like, right? And nobody knows what that feels like. But now we can say we know what that feels like. You can be anyone, anytime, anywhere. And limitless possibilities. So like, where do we start? So I've got a little clip, and then I'll be done. But so this is part of the interactive experience. So you walk up to this block, touch it, and all of a sudden you're on the deck of the ship, and you're just cruising through. Unremarkable in and of itself that you're standing on something in VR, but no, you're standing on a piece of history that has meaning, and it means something to a lot of people. I mean, this event arguably changed the course of world history. So pretty powerful stuff. Anyway, those are just some of the projects that we're working on. Many, many, many more people doing cool stuff. But we're, like Brian said, we're in this very exploratory phase right now where we're trying to figure out what are the use cases, right? Our customers deal in the quantifiable, at least the ones I deal with. So while Brian's like at the spear tip of all this stuff and he's doing all this radical, neat, amazing future stuff, I'm at the spearhead, but I'm like the part where like the stick gets jammed up into it, and the rubber meets the road. And how can we make these impactful, meaningful, value-added, quantifiably valued, not perception, but definitely on the numbers. This is how you do this. So that's it for me, and thank you for your time. And all of you, just on a side note, just want to say thank you for the games that you make. They very impactful in my life. Half the reason I'm standing here, I'm a huge gamer. I raise gamers, and so on a personal note, thank you very much. So.
Awesome. So pretty cool stuff Dave's doing here with our customers. All right, so just to kind of wrap it up. So in immersive design and contextual computing, it really allows us a fluency in how we experience things and understanding of digital information in context to the real world. And I think it's this fluency that increases the bandwidth between humans and machines and the data that we consume. And in this sense, contextual computing and immersive design gives us humans a superpower. Hopefully you saw some of that. It gives us the agency to experience the future before it happens and to experience our designs as if they're built and operating. To see the unseen, a sixth sense. Thank you very much. So I think we have maybe 5 or 10 minutes for some questions. So if anybody does have questions, feel free to come up to the mic and we'll take them.
Hey, I got first of all, a great presentation. Thanks for being here at GDC to talk about the use of VR and enterprise. I think that's awesome. A lot of great potential there. The question I had was, with your Autodesk Forge suite of APIs, are they, is it, apart from like using Forge, say, in Stingray, if I wanted to make my own sort of experience, and kind of utilize the functionality of Forge, the fact that it's so connected to all of your other tool sets, do you provide provisions to utilize Forge as an API outside of Stingray? Say I'm really good at Unity or really good at Unreal Engine or whatever.
Yeah, I mean, absolutely. So yeah, Forge is agnostic to the platform. So Forge works within systems of ours that are desktop applications. People have integrated with Stingray, but it's really any of those possibilities. And just to repeat the question was, do the Forge APIs and SDKs operate outside of Stingray? The answer is absolutely. They're completely separate. Forge is really a platform in the cloud that can be utilized by a variety of applications.
Okay, thank you very much.
Yeah.
Hi, my name is Danny. I'm doing VR for enterprise in China market. So one of the challenge for us is modeling is very expensive, even in China. But we're doing in outside China, our studio. So how there's a technology right recently. A lot of companies still working on that. Basically, you're using camera to take the model, and then somehow is there any things Autodesk working on to help reduce the cost of create a modeling by using camera, take a raw model and import to the Autodesk Maya or something, and using some way to human being manually fine-tune it. Basically reduce the cost of modeling or simplify the cost, also the speed up the modeling process. Mm-hmm. Is there anything you guys working on?
So just to repeat the question was, is there anything that Autodesk is doing to kind of minimize the manual, laborious task of modeling and make it more automated? Is that, yes. Yeah? So and Dave may have some answers to this too. Yeah, so I mean, the first thing, years ago, we invested in reality capture solutions, photogrammetry. We have a solution called Recap and Remake, which allows you to capture very, very high resolution, photorealistic looking models from photographs or from laser scans or LiDAR, or even combine multiple of those. So that's one example. We have research teams at Autodesk that are looking at just what the intent of designing something is and how to assist somebody. And then the other thing we're doing that we're really excited about is not humans designing anymore at all, where we're doing this employing generative design, where you no longer are designing a surface. What you're doing is you're specifying constraints and goals. So you would say, I want a support to be here, another support to be here, the load is here, the density is here, and you, computer, use the power of infinite computing in the cloud to go out and simulate that design tens of thousands of times and come back with a very optimal looking model or topology. So we do that for topology optimization and for truss. And I'm sure there's others. And I don't know, Dave, did you have any?
You got them, yeah.
All right.
That's good.
So, yep.
So I was really impressed by the live thing where you detected everything from Revit and the doors, etc. But you mentioned that in Stingray you can get more functionality in it. Is there any way to get some of that functionality that live creates in Stingray, but so that you don't have to rebuild that part? You mean I mean the doors and stuff like that, so that I can build over that, but I don't need to rebuild the things that live creates?
Yes, so you certainly can do that. It's more technically in depth, right? So that's just what Live does, is it leverages the data.
So when I go from Revit to Stingray, do I get that kind of data?
You go, actually, the path is through Live, so it's Revit to Live. And since Live and Stingray are both built on the Stingray platform, then you can easily just more or less, you have to change the file extension to .zip, but then you take the contents, drag that into your Stingray project, and you're good to go. Okay, so thanks. From there, that's where you'd have to build that functionality. So we're working on that, right? Continuous improvement, trying to get that live functionality into Stingray. But until that time, you would have to go in, find the door, say, this is the thing I want. When I get close, open it.
Got it. And one more, if you don't
sure.
mind.
Yeah.
You showed something very interesting for the automotive industry, the design with T-splines. Do you have anything like that in your pipeline for architecture? I work with some architects that really like modeling in that kind of way, with NURBS and tools that are more in that shape than the other ones.
Yeah, so we have a couple of things. One solution is called Dynamo. Dynamo is a lot like Grasshopper. I don't know if you guys are familiar with that. You can plug Dynamo into a variety of our systems. Could be Maya, could be...
But within VR too, or?
Yeah, there are people that have been experimenting a little bit with Dynamo into VR. I don't have a ton of details on that, but you know, those are things that they're sort of looking at to do this. You know, because we understand architects are really into generative design. We've got a number of projects at Autodesk that are looking at generative design for architecture types of industries as well. But I would say, you know, those are all things that people have been doing for years, like manually, and now we're trying to kind of automate it a lot better.
Thank you.
Yeah. All right.
As far as your sort of the VR tool set that you had the interns work on for the summer, is there a plan to follow up with that, either an integration into a tool like Autodesk Live or Revit, or is that your vision a standalone product for something like that?
So I don't know. I think what we are doing is we work very closely with the product teams to give them all our code, all our base, everything they need. But you know, when you start going from a research into a product, it's resilience, and you know, there's probably. So yeah, we have been talking about it, and we're looking at that. I don't have any specifics on plans or dates or anything like that, but yeah, we've been looking at that.
Cool. Yeah. Thanks, guys.
Hi. If one wanted to use some of these products to create like a product configurator for the customer themselves, would you have to design a UI in an external application, or would that be native to this?
Yes or yes. So what do you want? The intern project that I showed you there, they designed all the UI was actually 3D elements. They weren't even two-dimensional, and those were designed, I think those were developed in Maya, and then they were brought into Stingray and programmed through the Flow interface and the Lua interface. But you could also do it inside of Stingray directly. Stingray comes with an entire graphical, you know, for creating UX inside of Stingray, which is called Scaleform, and now you can do 3D. So either or. Yeah. And I think I've got time for one more question, and then we'll have to wrap up.
Okay. So I'm in the automotive industry, and we want to use our CAD models in game engines. And when you go from surfaces to triangles, you usually end up with a lot of triangles, and then we sort of use Simplegon to bake geometry into textures. Are you working on implementing more of these things into VRED? Or
we're looking definitely at more than just Revit to optimize surfaces and all sorts of geometry, data, all of that. Yes, absolutely looking at that. Okay.
Any timescales in the future? Yeah, okay.
Thanks. All right, well, with that, I think I'll wrap it up. I just want to say thanks for everyone who's still here. Hopefully you guys learned something, and we'll see you later. Thanks.